How Animals Think, the Hidden Intelligence of the Natural World. Level B. 1. Intermediate. When people hear the word intelligence, they usually imagine humans. They think of language, math, technology, books, and big ideas. But intelligence is not only one thing, and it does not belong only to us. Nature is full of minds that work in different ways. Many animals do not speak, do not write, and do not build cities. Yet they solve problems, learn from experience, remember places, understand social rules, and sometimes even plan ahead. The more scientists study animals, the more one idea becomes clear. Animals are not simple robots. They are living beings with attention, emotions, and smart strategies. Their intelligence is often hidden because it looks different from human intelligence. If we expect animals to think like humans, we will miss what makes them special. So, what does it mean to say an animal is intelligent? It can mean many things. It can mean the animal can learn a new skill. It can mean it can remember information for a long time. It can mean it can understand relationships and social signals. It can mean it can use tools. It can mean it can communicate in complex ways. It can also mean it can adapt to new situations when the environment changes. In nature, intelligence is often practical. It is not about abstract ideas. It is about survival. Find food, avoid danger, protect babies, work with others, understand the seasons. Remember roots. Every brain in nature is shaped by these needs. This is why different animals have different kinds of intelligence. A dolphin lives in water and needs social cooperation. A crow flies and uses its eyes and memory. An octopus lives alone and must solve puzzles with its body. An ant is small but lives in a huge society. A dog is social and evolved to understand humans. Each mind is built for a different world. Let's start with one of the most famous examples, the crow family. Crows, ravens, and other similar birds surprise people because they act like clever little scientists. They can solve puzzles, open boxes, and use tools. Some crows can bend a wire to create a hook, then use the hook to get food. This is not a simple instinct. It shows flexible thinking. Crows also have strong memory. They can remember human faces. If a person is dangerous, crows can remember that face for years and warn other crows. They also remember places where food is hidden. For a bird, this is like having a mental map. Why are crows so smart? One reason is that they live in complex social groups. Social life creates problems. Who to trust, who to avoid, who is a friend, who is a rival. Another reason is that they use many different food sources. When food changes with season, you need flexible thinking. So the crow brain is like a problem-solving machine. Now consider dolphins. Dolphins also have high intelligence, but it looks different from crow intelligence. Dolphins are extremely social. They cooperate, play, teach, and communicate. They can recognize each other, and they seem to have individual personality. Dolphins can solve tasks in labs, but what is more interesting is their natural life. In the ocean, they work together to hunt. They coordinate movement. They share information. Some dolphins use tools too. In certain places, dolphins have been observed using sponges on their noses to protect themselves while they search for food on the sea floor. This is a kind of tool use. It is also cultural, because young dolphins can learn it from older ones. Culture is not only human. In some animal groups, knowledge is passed socially, not genetically. Now, let's move to elephants. Elephants are famous for memory, but their intelligence is also emotional and social. Elephants live in family groups. They show strong bonds. They help each other. They can recognize individuals, and they respond to feelings. They may comfort a stressed elephant. They may protect a weak one. They also remember water sources and paths over long distances, which is crucial in dry areas. Elephants also show something that looks like self-awareness. In certain tests, some elephants recognize themselves in a mirror. This suggests they understand that the reflection is me, not another animal. Mirror self-recognition is rare in nature. It is seen in some primates, dolphins, and a few others. It is not the only sign of intelligence, but it is an interesting one because it hints at a complex mind. Now think about octopuses. An octopus is very different from a crow or elephant. It is an invertebrate. It has a soft body, and many of its neurons are in its arms, not only in its head. The octopus is often a solitary animal. It does not rely on social life, yet it shows strong problem-solving abilities. Octopuses can open jars, escape from tanks, and solve maze-like tasks. They are curious. They explore objects with their arms like hands. Why would a solitary animal need such intelligence? Because an octopus lives in a world of constant danger. It has no hard shell. It must hide, escape, and adapt. Its mind is like a flexible system for survival puzzles. It does not think like a mammal, but it can still learn fast. Now, not all intelligence looks like tool use or puzzles. Some intelligence is about navigation and memory. For example, migrating birds travel thousands of kilometers. They use the sun, stars, magnetic fields, and landmarks. A small bird can carry a map of the planet inside its brain. Salmon return to the exact river where they were born. Sea turtles return to the same beaches. Bees find flowers far away and communicate directions to other bees through a dance. This is not human intelligence, but it is incredible information processing. Nature built many systems that solve complex tasks without language. Let's talk about bees for a moment. Bees are small, but they live in a highly organized society. A single bee brain is tiny, yet bees can learn patterns, recognize shapes, and remember flower locations. Most famous is the waggle dance, which bees use to share information about where food is. The dance communicates direction and distance. This is a kind of symbolic language, even if it is simpler than human language. Ants are another amazing example. An ant is very limited alone, but an ant colony can behave like a superorganism. Ants create trails, build structures, protect the nest, farm fungi, and fight wars. No single ant understands the whole plan, yet the colony works. This is collective intelligence. It is like a city where no one person controls everything, but the system still functions. Now, let's talk about dogs and cats, because their intelligence is close to us. Dogs evolved with humans for thousands of years. They became experts at reading human signals. A dog can understand pointing, tone of voice, and emotional mood. Dogs can learn many words and commands. But more importantly, dogs are social thinkers. They understand relationships in the family. They know rules. They can even manipulate, sometimes acting cute to get food or pretending not to hear when they don't want to obey. Cats are different. Cats are more independent. Their intelligence often shows in their ability to observe and choose. Cats can learn routines, recognize people, and solve simple problems, but they are not as motivated to cooperate. That doesn't mean cats are less intelligent. It means their intelligence is shaped by a different evolution story. Here is the main lesson. Intelligence is not one ladder where humans are at the top and everyone else is below. Intelligence is more like a forest with many different forms. Each animal brain is built for a niche. If you judge a fish by its ability to climb a tree, you will think it is stupid. But in water, the fish is a master. So how do scientists study animal thinking? They use experiments, observation in nature, and careful comparisons. They test memory, problem solving, learning speed, and social understanding. But they must be careful because animals are not Malinkia humans. If an animal fails a test, it might fail because the test is unfair. Maybe it uses a different sense. Maybe it is not motivated by the reward. Maybe it is stressed. Good experiments try to match the animal's natural behavior. One big example is decision-making. Animals constantly make decisions, even if they don't talk about them. A bird decides when to fly away from danger. A deer decides where to find food. A wolf decides whether to hunt alone or with the pack. These decisions are often bistry and practical, but they are not random. They are based on learning and memory. Many animals learn from experience in a way that looks very human. If an animal touches something painful, it may avoid it later. If it finds food in a certain place, it may return. If a certain route is dangerous, it may change routes. This kind of learning is not just instinct, it is adaptation. And sometimes animals make surprisingly smart choices when the world changes. Think about city animals like pigeons, raccoons, crows, monkeys, and even some foxes. Cities are complex and full of dangers, cars, people, strange noises, new objects. Yet many animals learn to live there. They learn where food appears, how to avoid humans when needed, and how to use buildings and streets. Some animals learn traffic patterns. Some learn when garbage is placed outside. Some learn which humans feed them and which humans chase them away. This shows flexible intelligence because cities did not exist for most of their evolution. They are learning a new world. Another hidden form of intelligence is planning. For a long time, people believed animals could not plan ahead. They thought animals only reacted to the present moment. But research and observation show that some animals can plan in simple ways. For example, some birds store food for later. Squirrels hide nuts. They remember where they placed them. This is a form of future thinking. It doesn't mean they imagine the future like humans do, but they behave in a way that prepares for future needs. Some animals even choose better hiding places when they know someone is watching. That looks like social planning. If another animal sees, they might steal. This brings us to another surprising topic: deception. Yes, some animals can cheat. In nature, cheating can be a survival strategy. Some animals pretend to be weak to trick others. Some birds may give a false alarm call to scare other birds away from food, then eat it alone. Some primates hide food from others. Some dogs pretend they didn't hear a command when they really did. Deception suggests an understanding of another mind, at least in a simple form. The animal acts as if it knows what another animal will believe. Now, let's talk about emotions, because people often say animals don't have emotions, they only have instincts. But if you watch animals, it is hard to believe they have no emotions at all. Many animals show fear, joy, frustration, excitement, and stress. Their bodies react. Their behavior changes. They seek comfort. They avoid pain. They form bonds. Scientists are careful with this topic because it is easy to project human emotions onto animals. But we can still say something important. Animals have internal states that guide behavior, and many of these states look similar to emotions. Fear helps survival. It makes an animal cautious. Social animals also seem to have feelings connected to relationships. They can show attachment, jealousy, and sometimes what looks like grief. Grief is one of the most emotional topics in animal intelligence. There are many reports of elephants staying near a dead family member, touching bones, and showing quiet behavior. Some primates have been observed carrying a dead baby for days. Dogs can become depressed after losing a person or another dog. Birds can become quiet after losing a partner. We cannot fully know what an animal feels, but we can see patterns that suggest loss matters to them. If loss changes behavior deeply, that is a sign of emotional complexity. 8. Now let's explore communication, because many people think animal communication is simple, just basic sounds. But communication in nature can be very rich. Birdsong is one example. Some birds have complex songs that change by region. This is similar to accents. Young birds learn songs from adults. That means song has a cultural element. Whales also sing, and their songs can change over time, like evolving music. These songs may serve social purposes, attracting mates, building group identity, or coordinating behavior. Dolphins use whistles and clicks, and some research suggests they may have signature whistles like name sounds. If true, that would mean dolphins can call specific individuals. Even if we don't fully understand their language, it shows that their communication is not just random noise. And communication is not only sound. Many animals use body language, posture, tail movement, ear position, facial expression. Dogs do this constantly. A dog shows fear by lowering its body. It shows confidence by standing tall. It shows play by a play bow. Cats use tail and ear signals too. Horses read each other through movement and position. Even fish use body signals in social situations. In insects, communication can be chemical. Ants leave zapic trails. They signal danger through chemicals. They recognize nest mates through smell. For an ant, smell is like language. Now, one of the most interesting ideas in animal thinking is culture. Many people believe culture is only human: art, rules, traditions. But in a broader sense, culture means learned behavior passed from one individual to another, not through genes, but through social learning. Animals can have culture. We already mentioned dolphins using sponges and passing that technique to young dolphins. Some primates use specific tools in certain groups, and other groups do not, even when they live in similar environments. That suggests the behavior is learned, not automatic. Some birds learn new ways to open trash bins or milk bottles, and the behavior spreads through a population like a trend. This is remarkable because it means animal societies can accumulate knowledge. They can build traditions. They can change over time. That is a kind of intelligence that exists not only inside one brain, but inside a group. And this brings us to a key idea. Intelligence is often social. A single animal can be smart, but a group can also create smart behavior. Wolves hunt in coordinated ways. Orcas hunt with strategies that seem learned and shared. Meerkats teach young ones about dangers. Social learning is powerful because it saves time. Instead of learning everything through painful trial and error, young animals can learn from older ones. So, why do we miss animal intelligence so often? One reason is language. Humans value language highly, so we often treat language as the main proof of intelligence. But intelligence can exist without human-like language. Another reason is our ego. It feels good to believe we are special, and we are special in many ways, but nature is also special. Different kinds of minds exist all around us. Another reason is that many animal skills are invisible to us. A bat uses echolocation. We don't feel it, but it is like seeing with sound. A shark uses electrical sensors. We can't imagine that. A pigeon senses the Earth's magnetic field. We don't have that sense. So, when we watch animals, we may not realize what information they have. When you understand this, you begin to respect nature more. A forest is not just trees. It is a network of minds: birds, insects, mammals, reptiles, and fish, all making decisions, learning, and adapting. The natural world is not silent. It is full of intelligence, just expressed in forms we often ignore. And here comes the final important question. If animals think in hidden, intelligent ways, how should that change us? It should change our attitude. It should make us more humble. It should also make us more responsible. If animals can feel stress, form bonds, learn, and suffer, then the way we treat them matters. It matters in farming, in entertainment, in pet care, and in how we protect habitats. Respect does not mean we must treat animals exactly like humans, but it does mean we should treat them as living beings, not as objects. It also changes how we see ourselves. Humans are not separate from nature. We are part of nature. Our intelligence is powerful, but it is one branch on a big tree. When we notice the intelligence of animals, we understand that life on Earth is not only beautiful, it is also clever, creative, and deeply alive. So the hidden intelligence of the natural world is not hidden because it is rare. It is hidden because we don't always know how to look. Once you learn to look, you start seeing minds everywhere. in the bird that remembers your face, in the dog that reads your mood, in the bee that dances directions, and in the elephant that stays close to family. Nature is full of thinking, and that makes the world richer than we usually imagine.